Welcome to the next portion of our series, a dozen methods, one data set, an applied walkthrough of the method map. Let's say your university thinks the student population is evenly split, half on campus, half off. But you've got a hunch. More students are staying on campus than that estimate suggests. How do you test if your observed distribution matches that expectation, or if it's significantly off? Our research question is, does the distribution of students living on campus versus off campus match a specific expectation, like a 50-50 split? Or do the actual counts suggest something very different? Let's talk about how we landed on the chi-square goodness of fit test. Here's what we're working with. We are testing a hypothesis and drawing comparisons, comparing students with different living status. We have one categorical variable, student living status, on campus or off campus. We're not comparing two variables. We're comparing observed frequencies to a theoretical distribution. And importantly, we have enough data in each category to meet the assumptions, at least 5 expected counts per group. That makes the chi-square goodness of fit test the correct method. And if you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. Start with your research question and hypotheses, both null and alternative. Define your variables clearly. What's the outcome? What's the grouping variable, and how are they coded? Describe your data preparation steps, including how you filtered, recoded, and structured the data. Explain the method you're using and how you calculated or entered group proportions. Mention any assumptions you checked, for example, having at least 5 expected cases in each group, when testing groups with proportions or categorical variables, or testing for linearity in a regression. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. This structure turns a simple test into a publishable mini-study. The chi-square goodness of fit test helps us determine if the pattern we observed in our sample matches what we expected to see. The test gives us the observed counts in each category, the expected counts based on our hypothesis, a chi-square statistic measuring how different they are, and a p-value that tells us whether those differences are statistically significant. If that p-value is less than 0.05, we reject the null hypothesis and say, the distribution in our data is significantly different from what we expected. Here's how to run the chi-square goodness of fit test in SPSS. Go to Analyze, Non-Parametric Tests, Legacy Dialogues, chi-square. Select your variable, here, that's living status. If you're testing an equal split, enter expected values as 50-50. Or if you have a custom expectation, like 60% on campus, adjust those proportions accordingly. Click OK. The output gives you observed versus expected counts. We see the expected, given we set the test at equal, so 50-50, that we should expect to see about 729 students in each category. Clearly, this is very top-heavy on campus, so this is not what we see in the observed, which leads to the chi-square value, which is 993, which is, well, high, and yields a p-value of below 0.01. If the p-value is under 0.05, that's evidence our observed distribution does not match the expected one. And that wraps up the chi-square goodness of fit test. It's a powerful way to test whether the pattern in your data aligns with what you expected. In the next video, we'll shift from comparing one variable to testing whether 2 categorical variables are related. That's where the chi-square test of independence comes in. If you're enjoying this series, make sure to subscribe and follow along as we keep building from one method to the next.